You throw a ball upward with an initial speed of 18 meters per second. How high does it go and how long is it in the air? So let us solve this problem. Let us first know the given. So from the problem, the given is the initial speed of the ball. Let's say VI, the initial speed. It is 18 meters per second. So how high does it go and how long is it in the air? So we are required the maximum height. Let's say it is Y, the maximum height, and second is the time the ball spent in the air. So how now do we solve for this problem? The given was just the initial velocity, but we all know that after you throw the ball will be in free fall. So the only force acting on the ball is gravity. Therefore, the acceleration due to gravity is acting on the ball. So we have gravity equal to, by magnitude, is 9.8 meters per second squared. Now, what equation can we use from the kinematic equations? We are given initial velocity. We are looking for y, the maximum height. So from our kinematic equation, we can use the equation v final squared is equal to vi squared plus 2gy. But our v final squared, remember that at the peak of the ball, when you throw the ball at the maximum height, the final velocity is 0 because it will momentarily stop. So this term will be equal to 0. Therefore, rearranging this equation, we will have 2gy be equal to negative vi squared. Dividing both sides by 2g, we'll have cancelled. Y would be equal to negative vi squared all over 2 times gravity. So we'll have y be equal to negative v initial. The v initial is 18 meters per second. 18 meters per second squared all over 2 times the gravity, negative 9.8 meters per second squared. Y now is equal to negative 18 meters per second squared divided by 2 times negative 9.8. So the answer will be 16.53 meters. So the maximum height is 16.53 meters. Well, how about for the time? How can we compute for the time? So from our equation, Vf is equal to Vi plus Gt. Again, this V final will be equal to 0. So this will just be the time going up. We'll have Gt is equal to negative Vi. We'll have this G over G So time will just be negative vi all over gravity. So this is negative 18 meters per second all over 9.8, negative 9.8 meters per second squared. So computing for this time, we have negative 18 over negative 9.8 is 1.836 or 1.84. 1.84 seconds. But this is not our final answer because from our analysis, this is just going up, going to the maximum height because we set our final velocity to 0 at the maximum height. So this is just the time that the ball travels downward going to the maximum height. But with the principle of symmetry, if the time of the ball going up is 1.84 seconds, let's say this is the maximum height, then it will go down at the same time. This is 1.84 seconds, another 1.84 seconds. Therefore, your time total, you will just have to double this time. 1.84 times 2 is 3.6734 or 3.67 seconds. We can actually confirm this answer by using another equation, but we'll just have to rely on our calculator because the answer will be, we'll have to answer. It will be a quadratic equation by using the formula y is equal to vi t plus 1/2 gt squared. So remember that our y is the displacement. Okay, this y is the displacement of the ball. So if we are to determine the displacement of the ball from this point going up and then going down up to this point, our displacement, the total displacement of the ball will be 0 because it just returned to the original position. Our v initial is 18 meters per second, 18 meters per second, and we'll have 1/2 of the gravity, negative 9.8. This is t. This is also t squared. Let us first do away with the units. So this will become 0. 18t minus 1/2 of 9.8 is 4.9 t squared. So this becomes a quadratic equation. Rearranging it, we'll have negative 4.9 t squared plus 18t is equal to 0. Now we can solve for t using our calculator. Just setting our calculator and mode. Let's have equation. So mode 5. What type of equation? This will be a quadratic equation. 3 x squared plus bx plus c equals 0. So this is mode 5, 3. Let's input our numerical coefficients. Negative 4.9, then 18. We have no constant, 0. Let's just press equal. So the first root that we get Let's say this is T1, 180 over 49 or 3.67 seconds. We'll have another root of this equation, which is 0. So this is our answer, confirmed by using another equation, 3.67 seconds. Therefore, we are correct. So the answer for the height, the maximum height is 16.53, and the total time spent by the ball in mid-air is 3.67 seconds.